Okay, so we are on to Unit 2, Lesson 6, Ratios, Rates, and Conversions. So this is going to be a lesson that ties directly into the next few lessons. So it's important to know what a ratio is, what a rate is, and how to convert units. So the first thing we're going to do is we're going to define a ratio. And all we have to know about a ratio is that a ratio is something that compares two numbers using division. So it compares two numbers using division. 2 over 5 could be a ratio. So it compares two numbers using division. Now a rate is a special type of ratio. It's a ratio that compares two quantities. So a rate compares two quantities. Now a unit rate compares two quantities as well, but a unit rate is a rate that compares two quantities. So it's a rate with a denominator of 1. So a unit rate, an example of a unit rate would be miles per hour. How many miles can you travel in 1 hour? A unit price. How much does each of something cost? Okay. So those are some of the common rates and things we're going to talk about. So when we talk about converting units, we use a conversion factor. A conversion factor is a ratio of two equal measures in different units. Okay, different units. So like a minute and 60 seconds are equal measures, but they're in different units. In a foot and 12 inches. Equal measures in different units. Okay, and then finally, unit analysis. So unit analysis is a process that we use to determine units for answers. So if you were solving some sort of problem where you needed to figure out how far you needed to travel for a road trip, you probably wouldn't use inches or feet. You would probably want to work in miles. So you're using unit analysis in case you need to convert between units to solve a given problem. Okay? So to get into this, we're going to talk about comparing unit rates. And this is an extremely important thing, especially if you've ever bought anything. So you're comparing 3 different stores and comparing their prices for t-shirts. So if I want to find a unit rate, I'm going to compare the price for one t-shirt to figure out what the best deal is. So in store A, the unit rate, it costs $25 for 2 t-shirts. So that unit rate would be $12.50 per shirt. It cost me $12.50, $12.50 to buy one shirt. In the next example, in store B, 45 shirts, $45 for 4 shirts. So I'm going to divide that out. 45 divided by 4 is 11.25. So for store B, it costs 11.25 per shirt, for one shirt. You're going to hear me use that word per a lot. That means for each shirt. So the unit rate means it's this many units, this many dollars for one shirt. So already, store B is a better deal than store A. And then store C, $30 for 3 shirts. 30 divided by 3, that would end up being $10 per shirt, $10 for each shirt. So the best deal would be the cheapest unit price, which would be store C. store C would be the best deal. Because they offer the cheapest price per shirt. You're getting the best deal you're getting the most shirts for the least amount of money, or the same amount of shirts for the least amount of money. So store C would be the best deal. So in this next example, maybe pause the video and try this one, and then I'll explain. It says if store B lowers its price to $42 for 4 shirts, does the solution change? So we're keeping store A and store C. They're keeping their prices the same. Store B maybe has some sort of sale where they say $42 for 4 shirts. So $42 for 4 shirts. 42 divided by 4 is $10.50 per shirt. Now that is cheaper, but it doesn't change. No, it doesn't change. We would say the solution doesn't change. Ooh, I'll write that better. The solution doesn't change. And the reason it doesn't change it doesn't change because store C still has a cheaper unit price. Store C is still cheaper per shirt by 50 cents a shirt. So store C is still cheaper. It doesn't change. It does make their shirts a little bit more affordable, a little bit better deal, but not as good of a deal as store C still. Moving ahead. Now converting units. What I'm going to try and do is I'm going to try and explain units the best way I can, and I'm going to try and not give you too many super complex units to convert. So these are going to be common ones. I think common ones that we are going to deal with if you ever take science. So if I'm going to convert 330 minutes to hours, I'm going to write out 330 minutes, and then it might be helpful to know how many minutes are in 1 hour. So I know there are 60 minutes in 1 hour. So I'm going to multiply this by a ratio comparing minutes to hours. And I'm just going to show this as 1 hour contains 60 minutes. So this is our conversion factor here. Okay, this is our conversion factor. 1 hour to 60 minutes. And essentially what happens is we divide out our common units. So in this case, our common units are minutes. So the reason I put minutes on the bottom is so that I can divide out those common units. So to calculate this, I would take 330 times 1, which is 330, and I would divide that by 60. Okay, so 330 divided by 60 is 5.5. So 5.5 hours. So we solved it. We converted what we needed to. We converted from 5.5 hours, or from 330 minutes to 5.5 hours. So we wanted to get hours, we got hours. Now, moving ahead, 15 kilograms to grams. I'm going to start with 15 kilograms. And it would be important to know how many grams are in a kilogram. So kilo is 1,000. So that means that 1,000 grams are in 1 kilogram. So to set up this one, I would take my ratio and I would say 1,000 grams over 1 kilogram. And again, I put kilograms on the bottom because those units are common units and they divide out. So I would do 15 times 1,000, which would be 15,000 divided by 1. 15,000 divided by 1, this would be 15,000 grams. And that's converted. So you think you're going from a larger unit of measure to a smaller unit of measure. Moving ahead, part C, 5 feet 3 inches converted to inches. First thing I'm going to know is I already have 3 inches, so I can represent this as 5 feet plus 3 inches. So to kind of simplify this, I'm going to convert 5 feet to inches, and then in the end, I'm going to tack on 3 inches to whatever I convert, because I know there's 3 inches as part of that. So I would represent this as 5 feet. To convert that to inches, that would be 12 inches are in a foot. So I would put 12 inches on the top, 1 foot on the bottom, so that those common units divide out. 5 times 12 is 60. 60 divided by 1 is still 60. And I just got to remember, I've got to add on 3 inches at the end. So that's 63 inches. So what that means is if you are 5'3", you're 63 inches tall. Okay, you're 63 inches tall. Okay, and then finally for converting 1,250 centimeters to meters, 1,250 centimeters. And then for my ratio I'm going to write, I've got to know how many centimeters are in 1 meter. So centi, think of cents. There's 100 cents in a dollar. For centimeters, there's 100 centimeters in 1 meter. So the way I'd set this up, I'd say 100 centimeters on the bottom, 1 meter on the top. So that's an important part of this, is knowing centimeters goes on the bottom so that these units divide out. So what this becomes is 1,250 meters, if we want to keep that as our units, and that's divided by 100. So 1250 divided by 100 should be 12.5 if I'm doing this right. So that's 12.5 meters. So remember, you got to know some of these conversions. If there's one that I think is uncommon, I will give you that conversion factor. I will say, if you didn't know, there's 5,280 feet in a mile. I would give you that. But if you know common ones, kilo, we should know as 1,000. Centimeter, we should know as 100. But past that, you guys will be given the units if I don't think it's a common one. So I know this was a little bit long of a video. It's mostly because I was going through the vocab. So you can move on to the next step in the lesson. You're going to get some practice comparing unit rates and converting units.